Hey all, this is Alan with Bothell STEM Coach, and today we are finishing up the AP Calculus 2004 free response questions, and we'll look at number 6 here. So consider the differential equation dy dx is equal to this. Sketch the slope field for the given differential equations. Okay, so you just got to take each of these points and plug it into this equation. So let's do some simple ones. When x is 0, this whole thing will be 0, right? So these are 0 slopes right here, because these are all the points where x equals 0. Also, when y equals 1, they're also 0 slopes. Okay, so that was pretty easy. Now let's look at negative when y is 0 and x is negative 1. Negative 1 squared is positive, it's 1. When 0 and minus 1 is negative 1, so 1 times negative 1 is negative 1, so it's negative here. And then when I have negative 1, positive 2, that makes this 1. 1 times 1 is 1, positive 1. And then when I increase it to 3, this would be 2 times 1, that becomes 2. So I'm just plugging in the x and y coordinates of each point into this equation and then sketching a slope. It should be even. So like when I make x positive 1, it does the exact same thing as it did over here. So this is 2, this is 1, and this is negative 1. Okay, and that's it. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points of the xy plane for which the slopes are positive. So I want to know when x squared times y minus 1 is greater than 0. X squared is actually always greater than 0. So it's only when y minus 1 is greater than 0 that I have to worry about. So that means y is greater than positive 1. Y is greater than positive 1, and x is not equal to 0. I guess technically, if you want to be, because I don't want to be exactly 0. Find the particular solution to the given differential equation with the initial condition f of 0 equals 3. So to do that, we do separation of variables. I bring the dx up to this side, and I bring this to the y, everything with the y down here by multiplying or dividing. So I have dy over y minus 1 is equal to x squared dx. I take the integral of both sides. This is just natural log y minus 1 is equal to 1/3 x cubed plus c. Take e to the both sides. So I have an absolute value of y minus 1 is equal to e to the 1/3 x cubed plus c. But I always, this plus c, I write that as e to the 1/3 x cubed e to the c, or I just combine that into a single constant, c e to the 1/3 x cubed. Now at this point, you kind of have to, you don't really know if c is positive or negative, I guess. Well, let's plug in f of 0 equals 3. So that means that absolute value 3 minus 1 is equal to c e to the 1/3 times 0 cubed. 0 cubed is 0, so that's c is equal to 2. So I have absolute value of y minus 1 is equal to 2 e to the 1/3 x cubed. And then I think because y is already positive, you can assume that the absolute value, like it's not going to cross through. Well, is it going to cross it? So f of 0 is equal to 3. So I'm at this point. So I think like when I go to the right, it'll be positive slopes. So these slopes will always be positive. And when I go to the left, I won't ever cross into the negative because this is the equilibrium solution. So you can actually get rid of the absolute value signs, because you know that like y is always going to be above 1. If I start out up here, like my solutions will only converge towards 1. And so that means y is equal to 2e to the 1/3 x cubed plus 1. So just remove the absolute value signs. Okay. All right. Let's look at the answers. These look right. X is not equal to 0 and y is greater than 1. And then 1 plus 2, 1/3 x cubed. Okay. Let's see. Okay. Hope you found that helpful. And I will see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.